All right, so this is question 5 from the week 3 math counts handout, and it says, there's this figure right here, and it shows a circle inside of a square that's inscribed in a larger circle. And so the larger circle has an area of 256 pi millimeters squared. And so it's asking what's the radius of this smaller shaded circle. And of course it says, express your answer in simplest radical form. All right, so what's important here? Well, we know we have, 3 shapes, 2 of which are inscribed in this larger circle. And then another thing that's really important is that the area of this large circle is 256 pi millimeters squared. Okay, so we know that the area of any circle, that's just going to be equal to pi r squared. And so in the case of this larger circle, well, that means the area of the circle, pi r squared, is equal to 256 pi millimeters squared. So if the pi's cancel out, we get that r squared is equal to 256, which means that r is equal to the square root of 256, which is 16. So the radius of this big circle, well, that is just 16. Well, then what about the diameter of this big circle? We can use that because we know that this length right there, that is another 16, because that's also the radius of that big circle. So that means the diameter of the circle is twice the radius, right? The diameter is going to be 32. And this is really helpful because the diameter, we can make a right triangle with the square from the diameter of the circle. And because we know that both of the 2 side lengths of the square are the same, well, this is a special right triangle. This is a special right triangle called an isosceles right triangle where both of the side lengths, sorry, my drawings are always so unstraight, but both of the side lengths, if they're the same and it's a right triangle, this is a 45, 45, 90 degree triangle. And so the hypotenuse is going to be x, so the side length or the leg, times square root of 2. The hypotenuse of this triangle, it's just going to be 32, right? As we said before, it's just the diameter of the circle. So if we know that 32 is the hypotenuse, and that's equal to x root 2, well, the legs are going to be just x. So that's going to be equal to 32 divided by square root of 2. And so we want to rationalize this because we don't want that radical sign in the denominator. So we do that by multiplying this by square root of 2 over 2. Because that right there, that's just 1. So even if we multiply it by it, it doesn't change anything. We're just trying to get rid of that radical. So this ends up being 32 root 2 over square root 2 times square root 2, which is 2, which ends up being 16 square root 2. So our legs are each 16 square root 2, which is really helpful because now, let's look at this. Well, we know the leg is 16 square root 2, so this entire length is 16 square root 2. That also means this length is 16 square root 2. That also means this length that cuts through the center of the circle, well, that's 16 square root 2. And hold up, doesn't that mean the diameter of the smaller circle is 16 square root 2? Yeah, exactly. It exactly does. So if the diameter of the smaller circle is 16 square root 2, and we're looking for the radius of it, well, then that's just half of that. So the radius of the smaller circle is equal to 8 square root 2, which is our answer.